So we have the weights of the neural network for the trained model with regularization, and we have the weights of the neural network for the trained model without regularization. I drew the weights of the connection between the inputs and the neurons of the first layer in a table. So these 15 numbers are these 15 numbers. Notice here that with noise 1, noise 2, and noise 3, each of the neurons has very small values, very close to 0. So the connection with the hidden layer from noise 1, noise 2, and noise 3, they're pretty weak. Now, what happened with the trained model without regularization? So this is the trained model without regularization. That means this table is showing these 15 values. As we can see, the numbers here in this part, that means between noise 1, noise 2, and noise 3, and neuron 1 and neuron 2 and neuron 3, they're not that much close to 0. So with regularization, they were very close to 0, and without regularization, they are not that much close to 0. So that's really excellent, because L1 regularization is helping us by stating that noise 1, noise 2, and noise 3, these 3 features have barely any weight with neuron 1, neuron 2, and neuron 3. And hence, X1 and X2 are good features that have some relationships with our neurons. So X1 and X2 are good features that are helping the neural network reduce the output error. In terms of feature selection, looking at the weights, we can say that X1 and X2 can be the selected 2 features. And L1 regularization helped us with that. Without L1 regularization, noise 1, noise 2, noise 3 are still somewhat connected to neuron 1, neuron 2, and neuron 3. Let's go back to the code. This particular investigation is not about what is the accuracy of the testing part. It's more about if the neural network weights can help us in selecting features. Let's still do the model evaluation through the test data, because remember that we had 20% test data separated in the beginning here. So let's do that testing and compare the mean squared error loss. So we wrote a function for model evaluation, and here we are evaluating the model with our trained model that has the L1 regularization and without the L1 regularization on the same test data in both cases. We see that mean squared error with L1 regularization is slightly higher than the mean squared error with no regularization, so they are pretty close. Depending on our observation with L1 regularization and these values connected to noise 1, noise 2, and in noise 3, we can say that in this neural network X noise 1, X noise 2, and X noise 3, these 3 features are not much important. These 2 features are the most important ones. And that matches with what we started this video with. Y is relevant to X1 and X2 only. Y is not related to these 3 features at all. In practice, if you have too many neurons in the hidden layers, you might not see this kind of great result, because those zeros can spread over the internal hidden layers, and the understanding of the connection between the features coming from input to the first layer will be lost. So if you want to select features, then probably it's better not to provide too many hidden layers, maybe 1 or 2 hidden layers. Since we only had 5 features, I just provided 1 hidden layer with 3 neurons, and it was sufficient for this simple dataset. Thank you very much for watching. See you soon in another video.